to solve at question number 6. What do we have here? Jill is the manager at the bookstore that sells the calendars featuring local photographs. She orders them from a supplier that charges $6 per calendar for orders received by November 1st. Okay, so we know that Jill is paying $6 per calendar. Okay? $6 per calendar. Alright, let's read next. Jill sells this calendar to her customers for $15 per piece. Pretty good, huh? $9 more is sell per calendar. Okay? Any unsold calendar can be returned to the supplier in February for credit $3.50. Let me put this way. Leftover can sell for $3. Leftover return. Okay, return leftover $3 per calendar. All right. Or $3.50? $3.50, okay. All right. So Jill estimates the demand level for the calendar will be 500,000 and 1,500. Here it shows here demand and supply. Okay, so we're gonna work with this amount of demand. And these are the order quantities she's choosing among. So we need to construct decision table for Jill. All right, how are we gonna work? So first thing we're gonna know is what's the revenue, okay, for demand. For demand 500,000 and 1,500 with supplies accordingly 500,000 and 1,500 calendars. So first thing, let me write down here, make a table. I'll make table here. So it's gonna be 500,000, 1,500. This is demand. And supply is gonna be 500,000 and 1,500. Okay, let me change the color so data and the rest it won't be confused. Okay. All right. So let's go for revenue. No. First, let's see how much it's gonna sell the revenue. So, revenue for the sold calendars. So we have 500 and supplies also 500. All is good. So we have 500. It's gonna be 500 times how much is selling for 15, right? For $15. 15 times 5, it's gonna be 75 and 2 zeros, so 7,500. So that's 500. Leftover, it's gonna be 0, right, in this case, because we have 500 and demand also 500. Leftover is 0. Correct? So the cost, how much it costed him, costed her 500 times how much she paid, $6. So it's 33,000, which means profit is going to be equal revenue plus leftover and then minus cost, correct? So it's equal 7,500 plus 0 leftover and minus 3,000. So it's going to be 4,500. All right, let's put here profit is going to be 4,500. Where from is this line? Okay. Next, let me make the line. Now we're gonna work with when demand is 1,000 and supply is 500. So who cares that demand is 1,000? We can supply only 500, right? Therefore, we are going to have, so revenue from sale, it's gonna be again 500, right, times 15, 7,500, right? This dollar sign, let me clean. Okay, so next it's gonna be whatever leftover. Do we have leftover? No, because it demand is too many, but supply is not enough. So leftover is gonna be 0, right? We will sell all 500 that we can provide. And the cost is gonna be the same way, right? $500 times 6, it's gonna be 32 zeros dollars, and profit is gonna be again 7,500 minus 3,000, 4,500. All right. Now we go 1,500. For the case when demand is 1,500 and we have 500, it's going to be the same way, right? Because we can provide less than demand. So again, it's going to be 4,500. There is nothing left over, so we can return, make some money. Everything is sold. Moving to demand 500, supply 1,000. Demand 500, supply 1,000. Let's see how much we're gonna be in loss or we still will make profit. Let's see it. So demand 500, but it's gonna be only 500. The other 500 gonna be left over. So 500 revenue from sale, it's gonna be 500. So 500 from this 1,000, right? Times 15, it's gonna be 7,500. And leftover is gonna be how much? This 1,000 minus 500, correct? It's gonna be 500 total. And times $3.50. Right? Okay. And 500 times 3.5 times 500, it's gonna be 25, 15, 17, 1,750. Okay, so what we're gonna do next? Next we're gonna find the cost, right? Okay. So cost is gonna be total, how much we have? 1,000, right? Supply times $6, right? It costed $6. She bought for $6. It's gonna be 6,000. All right. Let's do the math. It's gonna cost the profit 7,500 plus additionally 1,750 and minus cost 6,000. Yes? Well, let's see. The 1,750 plus 7,500, 0, 5, 12, 8, 9, and minus 6,000. It's gonna be 0, 5, 2, and 3,250 profit. Is that right? I'm kind of doubting. Let me double check. 1,750, 0, 5, 12, 8, 9. Okay. Blah, blah, blah. 3,250. All right. So it's gonna be here 3,250. Okay, next we have 1,000. I'm going to go 1,000 with 1,000, demand 1,000, supply 1,000, right? Let's do it real quick. So revenue from 1,000. Let me write down here 1,000 so you will know which supply. This is supply. Okay, demand 1,000, supply 1,000. So 1,000 times 15, right? It's gonna be 15,000. Left over, it's gonna be 0, right? Because demand 1,000 and supply also 1,000. Then cost is gonna be, so 1,000 times 6, right? 6,000. All right, and the profit is gonna be practically 15,000 minus 6,000. It's gonna be 9,000. Okay, and accordingly for 1,500 demand, it's gonna be same 9,000. No, hold on, let me do it. We will have, no, we don't have leftover. Okay, so demand is more than supply, so we won't have any leftover, so which means it's still gonna be 9,000. Practically same numbers. It's gonna be different story now when supply is more than demand. That's what is gonna be interesting. So let me write down revenue. I'm putting now for 1,500. Actually, if demand is 500, then it's going to be 500 altogether, not 15. 1 second. Revenue from 500 is going to be 500 times 15, 7,500 $sign. Leftover, how much we have left over? We have 1,500. We're doing this one, right? Leftover is going to be 1,500 minus 500. We realize 500 and leftover 1,000, and we can sell, return it for $3.50. So we get here 1,000. So 3,520, 3,500. Okay, and from in cost, let's see how much will be cost. Guys, this is $sign, so you won't get confused what it is. Cost is gonna be revenue 7,500 plus leftover. It's still some money we got, and minus. I'm doing profit. Looks like I got enough. It's confusing. Okay, cost is gonna be 1,500 times $6. So 6 times 5 is 30, 3 in mind, 90, and 2 zeros, 9,000. Ooh, we are going, looks like, are we going to, no, looks like it's gonna be still profit, we'll see. Profit is gonna be 7,500 plus 3,500 and minus 9,000. So let's see what we have. 7,000 plus 3,000, 10,000, and 500, 500, 11,000 minus 9,000. Good job, still 2,000 profit. All right. Next one, it's gonna be 1,500 supply, 1,000 demand. Let me write down. This is 2,000. And this one. Okay, let's do this one now. Revenue from sale. So, okay. So we are going to take 1,000 because demand is 1,000 only times 15, right? We get 15,000. And leftover, how much we have left over? 500, right? So, because 1,000 we realized, we sold it, 500 left. 500 times 350. So 35 times 5, 25, 15, 17. Yes, let me double check. Yes. 2 zeros, so 1,750. Okay. And accordingly, cost is gonna be 1,500 times 6. 30. So 15 times 9,000. And revenue is equal 15,000 plus 1,750 and minus 9,000. Okay, let me see. So 15,000 plus 1,750, it will be 16,750 and minus 9,000. It's gonna get 7,000. Let me clean this. 7,750. Okay. So and lastly, 15,000 demand, 15,000 request. Let's do that also. So revenue 1,500 times 15, 15 squared is 225, 1, 2, 22,015. Leftover will be 0 because demand 1,500, supply 1,500. Cost is gonna be 1,500 times 6, 99,000. And from here, revenue is gonna be 22,500 minus 9,000. It's gonna be 13,500. Finally got it. Let me transfer to the grade. Oh, okay, hold on. Let me take a picture of it. And then I'll transfer to MyMathLab. Okay. Oh, looks like it got timed out. See? It says customer sold for $13 a piece. We have $16. I can't enter it. It won't match the answers. So at this point, you just know where to fill out the table and check it. All right, at this point, I will move to question number 7. Let me see what we have. Consider accompanying payoff table. This is payoff table. And we need to complete part A through E below. Great. A, B, C, D, E. No more, no less. Let's have fun. So question number 1. Choose the best alternative using Maximax. Maximax is, that means we have to choose maximum from each the alternatives. Maximum for alternative A is 1300, for B 1800, C 2400, which means the alternative is going to be C in my case. Okay, because it is the maximum payoff of highest all actions. Okay, well done. Next, maximean. Maximean, we need to choose the minimum from each alternative, and among these minimums that we find, we need to choose the max one. So in this case, we have minimums in demand level 1, right? A is 600, B is 200, C is negative 700, and the highest among them is A. So I'm choosing A because it's average minimum payoff. Yeah, it's the highest of all action, and it's maxi minimum payoff is the highest of the highest of all actions. Okay, you choose highest among minimum. Next one, using choose the best alternative using the equally likely criterion. So what we're gonna do here, we're gonna find the average for each alternative. Find the alternative, each average for each alternative, and choose the one that will have the highest one. So at this point, I'm going to get average. Let me see. For average for my A, and write down on piece of paper. I don't want to open, I would like to do it in Excel spreadsheet, but not on iPad I can, so I'm going to do by hand. If whoever is remember average, you just in Excel open formula, average, and then highlight on this alternative A, 600, 900, 1300, alternative B, and so on, and get the average. So for A, I'm going to have 600 plus, I'm doing manually, 900 plus 1300, and I put equal 2800, and dividing by 3, I get 900. I'm going to write down 933. That's for A. Okay. For B, it's gonna be 200 plus 1000 plus 1800. It's total 3000 divided by 3. It's gonna be 1000. And lastly, for C, it's gonna be 800 plus 2400 and minus 700. It's going to be 2500 divided by 3. It's going to be 833. So at this point, I'm going to say the highest payoff, average payoff, it's going to be A in my case. because it's no, I'm sorry. In my case, it's gonna be B. Yeah, in my case, it's B. I have 1,000. It's the highest one. Opa, it doesn't let me. Okay, B. Um, because it's an alternative based on the equally likely criterion, because it's average payoff of the highest all actions. Okay, next we are going to choose the best alternative using the minimum regret criterion. Okay, here we're gonna do some math. First of all, let me tell you that the goal of minimax regret criterion that we did here in B, no, minimax is in D, yeah, in D. We did maximin in B. What we did, we found maximum among the minimum payoffs. D, we need to find the maximum, the minimum about among maximum the criterion. Okay, so let me see. I'm going to take a picture of this demand level. I recommend you take picture also so you can follow me. Take the picture of this table. Okay, let me see. I got it. So let's start working. Maybe I'll just write down that picture. So I would like to get new page. Where was that? New section. Oh, here, new page. Okay. Let's get new page. I want this one, no. This one. All right, so how we gonna work with this? Let me write down, make this table. Demand level 600, 200, negative 700. Demand level 2 is 900, 1,000, and 800. Demand level 3 is 1,300, 1,800, 2,400. Okay, that's alternative A, B, and C. All right, let's start working. So what we're gonna do in this case, identify take the best payoff for demand 1, 2, and 3. So best payoff here it's gonna be 600. Base payoff for demand 2, it's gonna be 1,000, right? And best payoff, I'm going by column. For 3, it's gonna be 1,800. No, I'm sorry. 2,400. Okay, now I'm going to subtract each actual payoff in the column from the best payoff in column. So for 1, let me see, for demand 1, actually I don't want this. In ABC we have it. I'm going to do, the best is 600, so it's gonna be 600 minus 600, right? So it's gonna be 0. Maybe I should stretch a little bit otherwise I won't make it so much space. Here it will be 2, here it will be 3. Okay, it's gonna be 0, and then 600, because it's the highest one, 600 minus 200, it's equal 400, and then 600 minus negative 700 is equal 1300. Okay? Next, in B, alternative 2, I'm going to do the same way. So maximum is 1,000. 1,000 minus 900, it's gonna be 100. And 1,000 minus 1,000, it's gonna be 0. And 1,000 minus 800, it's equal 200. And the same thing I'm going to do with the demand level 3. Okay, demand level 3. That's going to be maximum 2,400. So 2,400 minus 1,300, it's going to be 1,100. Okay, 2,400 minus 1,800, it's going to be 600. And 2,400 minus 2,400, it's going to be 0. Okay, so let me see. I'm going to shade here. Those are answers we get. It's a table. And which one, which alternative with lowest maximum is which alternative has the lowest maximum? Let's see. Alternative A, lowest among lowest maximum is 1,100. Alternative B, lowest maximum is 600. 1,100, 600. Alternative C, the lowest maximum is 1,300. Right? And at this point, alternative with lowest maximum in this case, lowest of all maximums among 1,100, 600, and 1,300, the lowest is 600, right? Therefore, the answer is going to be B. Let me go to number 7, D. So the alternative is B. Is the best alternative based on the minimax regret criteria, because let me see what we have, because its maximum is the lowest of all actions. Okay, so the word minimax, meaning we are looking the minimum among the maximum. The word maximin, we are looking the maximum among all minimums. And when it says equally, we are using the average. Okay, let me check what is wrong. Oh, I said B and put C. Okay. And let's work on our E. Let me see what we have here. The best alternative using the Hurwitz criteria with alpha 0.7. Okay, Let me tell you what is Hurwitz criteration. It's Hurwitz criteration is defining. It's a criteration that allows the decision maker to simultaneously take into account both the best and the worst possible outcome. To do that, the decision maker will choose coefficient of pessimism that called alpha, which is a decimal number between 0 and 1. In our case, coefficient of pessimism is 0.7, quite a high, between 0 and 1. Okay, let's start working on it. So first of all, what we have to do is, let me write down. So Hurwitz criteration is equal alpha, which in our case is 0.7, right? Alpha times max value plus 1 minus alpha times minimum value. Okay, so we need to use our table. Let me see if my table, where is it? No, I need to write down all over again. So, oh, this is my table, 600, 900. Let me check. 1 second, I think that was my original table. Yes, 600, 200, negative 700. Yes, that's original table. All right, so let's get going in this case. So what was our worst payoff? Let me clean this. My worst payoff was for alternative A was 600, alternative B 200, alternative C negative 700, correct? Okay, the best payoff for alternative A was 1300, for B was 1800, and for C was 2400, correct? Okay, so now we're gonna take, see, we have maximum value and minimum value. And so what we're gonna do, we're gonna take our alpha 0.7 times maximum value for alternative A. Okay, the coefficient 0.7 times maximum value for A is 1300. Okay, and then plus 1 minus 0.7 times minimum value. In my case is 600. Okay, let me write down for the second one. B, alternative B, so 0.7 times maximum is 1800 plus 1 minus 0.7 times minimum is 200. And C, 0.7 times negative 700 no, to the maximum, I have to take the maximum, sorry, 2400, and plus 1 minus 0.7 times negative 700. Okay, so how much we will get here? Let me see real quick. 0.7 times 1300, it's 910, plus 600 times 0.3, 180, and the result is gonna be 1090. Okay, next, 0.7 times 1800, it's 1260, plus 200 times 0.3, you get 60, and plus 1260, yeah, it's gonna be 1320. And lastly, 0.7 times 2400, it's gonna be 1680, plus, oh, it's gonna be minus in this case because I have negative, right? Minus 700 times 0.3, 210, and I am getting 210, 8 minus 1 is 7, 4, so 1470. Okay, and alternative with the highest average, in this case, let me see, it's gonna be C. Yes, 1090, 1320, 1470. Let's go and put the answer here. So alternative C is the best alternative based on Hurwitz criteria, because the weighted average is how much we got? 1470, 1470. $170 is the, let me see, highest one. Okay, excellent. 9 and then 10, they are identical to 7, 8, 9, 10, so you can solve it. And in my next video I will record 11, 12, and 13. Okay, no, 10, 11, and 12, 13 from number 10. So 8, 9 are going to be identical to 7. You can do it. And in the next video I will record 10, 11, 12, 13, 4 questions. Okay,